Thank you for coming back. And so I'm Masaru Hiramo from the University of Tokyo, and today I'll talk about some kind of case study. And my research title is Selection of Related Stocks Using Financial Text Mining. So first of all, I'll explain about our research background. So our research background is about same mutual fund. So same mutual fund is like this, and this is same mutual fund, same robot and technology, and here is Atom. It is a famous Japanese animation character, and then building up this kind of mutual fund, it is pick up some stocks and get some stocks related to same and then build up this kind of funds, and then private investors invest in it. But however, building up this kind of fund is very difficult. So usually it built up by the fund manager by human, and then all over the world there are lots of stocks, and then even in Tokyo Stock Exchanges there are about 3,600 stocks. So pick up some related stocks and build up is very difficult. So in addition, to cover all thema or to cover all stocks related to the thema is quite difficult. So especially in case of the global fund, including stock abroad, is more difficult to make it possible. And then fund manager who build up to this kind of fund not similar to the thema. It is more difficult than similar thema. So our motivation is to support this kind of task for human. So here is a demo video we made, build up the supporting system and put the word on this box, and then after that companies ranking is appear on the left side, and then click the tick on the right side, the result appear. So right side word and similarity and files and reasoning sentence in Japanese appears. So currently this system only supported Japanese, but in future we will support also English. So next case is very interesting. So upper result is related pick up the word original sim fund robot, but go to the downside. There are other words similar to the original word. Robot is abbreviation of robot, and then mini robot. Here is mini robot in Japanese. So here is our system. So further building up the sim fund, usually fund manager use a web search or and so on. So input the word and the web search, and then pick up stocks by human hand. But our method outline is like that. So first of all, input the demo word like AI, and then using the word to beg, we pick up the related. Our system pick up related word automatically, like expert system or machine learning or natural language processing and so on. And then after that, we also use the company information crawled via internet, and then using this kind of data and feedback and modify the similarity from what's too big, and then using this modified similarity, we calculated the company's similarity and then according to the similarity, we rank the company similarity to the original table. So here is the outline. So in this system, we use some kind of data, and we use the data in what to back phase, and we use data as a company's information. So I explain about this kind of data. So we use 5 types of data, and we combine the 5 types of data and make it possible to pick up related companies. And then upper 3 one is for similarity. So upper 3 data is quite similar comparatively. So first one is live news corpus, and second one is very famous data corpus, Wikipedia Japanese article, and third one is a newspaper article from Nikkei, and this is a famous Japanese news company. And then in addition to this kind of data, we also use company information data. So we use 2 very different data. First one is investor relations. We call it IRs, and second one is offshore website. We call the offshore website of the listed companies. So usually investor relations is formatted as a PDF, but offshore website including a lot of types of data, of course including PDF, but mainly this kind of data is formatted as HTML files. So we combine this kind of data and made our system. So again, what's the back phase? We use 3 types of data, and in company information we use IRs and company's offshore website. Next I will explain about this feedback algorithm. So here is the feedback algorithm using the co-occurrence. This is an example of the same the word AI. So the pickup companies, including the word AI in their company's information. So this is in this example, we pick up the 1, 2, 3, 4, 5, 6, 7, and 9, 10 companies picked, and then same thing is done for the word NLP. So here is 1, 2, 3, 4, 5 companies pick up according to the company's information, and then in these 5 companies, only 4 companies are including both AI and NLP in their company's information. So we calculate the similarity between AI and NLP is 4 divided 5 equals 0.8, and then same thing is done for the other related words like machine learning and so on, and we also calculate this kind of similarity. So we use 2 kinds of similarities as I mentioned here. One is the similarity using words back, and second one is the similarity from feedback using co-occurrence. I explained about it previous slides, and then first one is similarity using words back, and we use different 9 models with different hyperparameter, and only using top 100 related similar words in each model, and combine this model, we took a harmonic average, and then the harmonic average is set as similarity from what's back. This is the first one similarity. So second one is similarity from feedback using co-occurrence. So combine these two kind of similarities and took a harmonic average, and we said it is a final similarity of each word. So using these similarities and then count the number of appearance of each top 10 similar words and original word in each company they do, and sum up the count weighted by these similarities, and we set this summation as a company's similarity, and not that original similar word weight like AI is set as 1. Here is all of our system. So next we show the result. Here is the result of the similar word to health. In this case, so this is the top 10 related word from our system. So these 10 words is very reasonable. So I'm sorry, this is Japanese, and here is the translation. So this top 10 words is very reasonable, I think. And then here is 11 to 20 similar words. So some of them is reasonable, but fourth word prevention is very weird. So what to make similarity is very high, but feedback similarity is very low comparatively. So because of it, final similarity is go down. So prevention is a very general word. So in the context of health, prevention is used with other words like prevention medicine or care prevention and so on. So prevention is a similar word in the context of health. So using only what this kind of words is go up to has a similar word, but using feedback algorithm, we manage this kind of bad point of words back. So next, here is the result of the company ranking list for which first theme is esports. So esports is a kind of game competition, and so because of it, GameWiz or Capcom or Kadokawa or Konami, these are Japanese companies. So some of you are not familiar with this company, but this company is very reasonable as a related company to esports. But PR Times is very weird. So PR Times is a company press the other companies press release. So we use offshore website data is granted as a company's information. So in PR Time company's website, there are a lot of other companies press release. So because of it, PR Times go up as a similar company. So however, our system show also reasoning sentence. So cooperate with human. It is very obvious to this is not related company. So our system is kind of partially worked with collaborative with human. So here is the evaluation. So evaluation, this is very new data. So this is only new data to this presentation, and our presenting paper, it doesn't contain this data. And we made answer data with 4 experienced fund manager, and then using Japanese middle or big stocks in topics 500 and pick up at random and make answer data. So one or more fund manager mark as a related stocks is tagged as related like this. So here is the result. We use for table, and then some of like care is a very high result, but the robot is a very low result. So from this result, it is very dependent on the same the result is good or not. So this is very new data. So we do not cannot deeper analysis, but this is a current evaluation. So here is the conclusion and contribution. So we built up the, as I mentioned, the systems supporting the fund manager to build up the mutual fund, and it partially worked. And we also use some types of kinds of data and collaborate with this data and make it possible to build up some mutual fund. And then as a future work, we have to pursue more recall. It means some noisy company appear on the list is maybe okay, because this system is meant to be collaborated with human, but dropping the related company is not good. So we have to pursue more recall and then check some of result. We find some crawling problem. So this is very technical problem, but the crawling problem means lack of data. So we have to fix this kind of problem. And also we have to tune some hyperparameter. So in this system, currently we use only top 10 similar words, but top 10 or top 20 or and so on is, and which one is good or not is not decided. So we have to tune some kind of these hyperparameters. And then, as I mentioned in previous slide, we also check the cause of the difference between good case or bad case. Thank you for listening.
Any questions?
So
yes.
So you estimated the similarities using two different criteria. So one is what they and the other is it's like mutual information, so PMI maybe. So did you evaluate the mutual relation between these two similarities?
So between
the two, yeah.
These two similarities.
A
So
and B, yeah.
of course, generally this similarity is very similar like this one. So what's big is higher. User feedback similarity is also higher, because what's big is some kind of the system thing regarded to context is as some kind of flow, and so, but our feedback algorithm is based on co-occurrence. So usually what higher similarity in words spec have a higher similarity in words spec. So a set of two words between in the word spec, usually in the data, two words is co-occurrence in each sentence usually. So our feedback algorithm is partially similar to word spec, but in case of this kind of words have a similarity in directory is very different similarity. So I think this algorithm combination is work. I think.
Any other question? Well, thank you very much for your.
Thank you very much.